Alright, next we'll look at the water plant routine. What we want to do when we water the plant is we want to check and see if there's enough water. If there's not enough water, we want to open the solenoid so enough water can be given to the plants, and then close the valve and check again. We want to keep doing this until enough water has been applied. Also, additionally, we want to also record the date and time whenever we do add water. So for this one, since it's going to be in a loop, we're going to, I guess something we want to continually do over and over again. We're going to start with a while. And we want to probably continue this one forever, so we're going to put in while one. So first thing we're going to do is take measurements. Let's add a quick comment there. And then next we want to check if there's enough water. And then if there is, then we're going to open the solenoid. Basically, if we need to add water, and if we don't need to add water, then we'll just be done, so we'll return. So then, and this is going to be like filler, so if okay. Okay. So to take measurements, we're going to be using the resistive sensors to read. So we're going to create a couple variables. Just some unsigned integers for val Q1, which is coming from the first quadrant. And we're going to read from the first quadrant of the resistive sensor. Oops. And then that will take a measurement from the first quadrant and store it into that variable. Then we're going to do that for all 4 quadrants. So let's do a quick copy paste. And I'm gonna take at least 2, 3, 4, 2, 4. Okay. So now that we have those 4 values, we're going to take an average of the values and see if there's enough water. So take an average of them. So we're going to add them all together. And then divide them by the total number, which is 4. And that'll be our new average. Okay, so if our average move the comment there. So yeah, if our average is okay, and let's declare a constant variable which will modify as we tweak it. Let's call it our minimum moisture value. And set it up at the beginning. Equals, for now, let's just make it some random number. Let's try 0, 1, 2, 3 in hex. That's what the 0x stands for. Okay. If the average is less than the minimum moisture value, then we're going to return. And otherwise, we're going to add water. So else add water. So we're going to open the solenoid. We're going to wait for 3 seconds. And we're going to close the solenoid. Okay. And the reason we're going to use functions here instead of using the power drive directly is because we can basically not have to change this partition of the code, only kind of the same way as we use the variable here, where we have one variable that we change. We're going to do the same with functions. So we're going to declare the open and close functions. And so and this is so for starting off, we're going to choose power driver A, but if we ever want to switch to power driver B, it's just simply changing which solenoid that we're going to be opening and closing. And the same for closing. There you go. And now to add the part about logging the values to file. So to log data to file, we start off by disconnecting the USB. This makes sure that the computer is not trying to read the SD card while the NISA board is trying to write to it also. Okay. Oops. Got the semicolon. Okay. And then we'll wait a brief moment just to make sure that the computer has unregistered the NISA board. So we're going to create a message. It's just going to be a character array or a string. And this will be pretty short. And we're going to fill it with zeros. Okay. Next, we're going to add the particular string that we want along with the timestamp. To do that easily, we're going to use the string library. So we go to the beginning of the main file and include that library. And if you notice that we're using the angle brackets, using the angle brackets is that tells MPLAB X that the system knows where this file is going to be. And we've configured it to know where to find the nisi.h. If you ever create your own header files, you'll most likely put those in double quotes. So the function we're going to use from the string library is sprintf. And we pass it our string that we want to write to. And then we're going to pass the formatting string, or what we want to write to it. And we want to say that we watered the plants. There you go. Just like that. But as an added requirement, we also want to add the time. So to do that, we're going to need to add a additional string that the function will format for us. So to do that, we're going to do a %s, which says take the string that we pass and stick it there. And the string we're going to pass is the current timestamp. We can get that from the datetime variable. So we do datetime, and we're going to get the timestamp. So get stamp, like that. And so then when we're done, it's going to say watered the plants, and let's add there. There you go. At that particular time. And then we want to log that data. So we're going to do data log, and then add. At the message was created, and then some code to go along with it. Let's say 48. Okay. Once we're done, we're going to reconnect to USB so that the computer can read our SD card again. And then that's it.